do you think you could solve the first example without me even showing you anything? What do you think you would do?
Plug in 4 to x plus 2.
Plug in 4 to x plus 2. And what do we get? 6. So then what do I do with the 6?
Plug in 6 to 4x plus 1 over x.
See, I don't even have to teach you guys anything. And so then I plug 6 into the G machine there, and I get, what, 25 over 6? Okay. Why don't you try f of negative 3? So you plug negative 3 into the f, get an answer, then plug it back into the f, right? So what do you get when you plug the first negative 3 in? Negative 1. And you get 1. Okay, everybody good with that? Okay. When functions are composed of other functions, as in example 1a and 1b above, this is known as function composition. When the output of one function is used as the input for another function, the resulting functions is called a composition of the two functions. I keep on saying that over and over again, aren't I? So notice that you can write this of f with an open circle g. That's why yesterday when we were doing multiplication, I stressed that the dot was actually filled in, because an open circle means the composite function. So f open circle of g means you take the input into g, get the answer, and then that is the input into f. So f open circle g is the same thing as f of g of x. Okay? So, and that's what I have coming up here. The function f composed with g is denoted f open circle g of x, and that's the same thing as f of g of x. The function f of g is obtained by substituting g for all occurrences of x in f. The domain of f of g of x is the set of all real numbers of x in the domain of that produce an output g of x. The domain of, I guess I'm going to say g. The domain of g that produce an output g of x, which now has a value in the domain of f. So what I'm trying to say there is, when I get an output x into g, and say that g was a square root function, do you see that domain now is restricted? So when I put that domain into f, it doesn't even matter what f's was, I'm restricted going in. Then on top of that, I might even have restrictions of f. So there's a lot of restrictions going on here, right? Okay, so let's see if we can figure out how to use this table. F of x and g of x. So first off, what does that mean, g of f of 3? What do I do first? I need to find f of 3, right? So where do I look on my chart? You look at x when it's 3, so that's the input. It's going into the f, and what do I get? 1. And then I have to find g of 1. So where do I look for that? Yes, I have to go back to the input. So this is like they put this table on the exam before, so you have to be able to read this. X represents the input into the function machine, okay? So you can't say 1 goes in and 4 comes out. You have to go back to the input. 1 is going into the input into the G machine, and we're getting 6. Do you see how that works? Okay, do you want to try B and C by yourself and see what you get? All right. Okay, so 2 goes into G, 5 comes out. Then I'm finding f of 5, and that means 5 comes out. Did you get 5 for the first one? Yeah? Does anybody want me to repeat that? Okay. And then 4 goes in, so 3 comes out. Then I need to find f of 3, and that means 1 comes out. Yes? Right on. Okay, moving on. What is the domain of linear functions? So a line, what's the domain? Yeah, it's all reals. What about quadratics? All reals? What about polynomial functions? All reals? Does everybody know that polynomial functions actually include all of the above? Yeah, it's a general term for them, yeah. Okay, what about radical functions? So what's the restriction? The inside of the radical, what is that called? The radicand. The radicand has to be greater than or equal to 0. So whatever that is. Does everybody know what I'm saying there? Okay. What about rational functions? It's essentially all reals. It's restricted to, I should actually put x as an element of reals, but the radicand has to be greater than 0. This one, x is an element of reals, but x cannot equal, instead of saying x cannot equal, maybe we should say the denominator cannot equal, because this is general, right? The denominator cannot equal 0. So whatever makes the denominator 0 is what my x can't be. Why am I going over that? So that when you have something going in, if there's a restriction, just to refresh your memory. This is pretty much all the functions we have. Of course, I haven't talked about logarithmic functions or exponential functions, which I'm sure will come into play. So when you consider composite functions, you must consider the domain restrictions. So is there a domain restriction of f? That's a quadratic. So is there a domain restriction? No. Is there domain restriction for g? Yes. What's the domain restriction? X has to be greater than or equal to 0. Yes. Okay, so g of 5. 5 is a legit number to go into the g machine, right? What happens when we get g of 5? We get the square root of 5. So then we're going to find f of the square root of 5. Yes? And that's legit to go into the quadratic because there was no restrictions, right? So then we get 4, subtract the square root of 5, the whole thing squared, which means 4 minus 5, which gives me -1. Is everybody good with what I did there? Okay. F of -1. So can the -1 go into the F machine? Yes. It's had no restrictions, so a -1 is fine. So -1 goes in there. What do I get? 3. So is 3 a legit number to go into the G machine? Yes. Okay, so then what do we get? Square root of 3. So f of g of x and state its domain. So we need to come up with a formula for f of g of x. So does everybody know what to do here? What does g of x stand for? The square root of x. Does everybody see that? So now I'm going to be finding f of the square root of x. If I plug that in, what do I get? I get 4 minus the square root of x, the whole thing squared, which just gives me 4 minus x. So you might think, oh, well, I can just plug anything into x because this is just a line now, right? No, hold it. Right here, there was a restriction going in. X has to be greater than or equal to 0. Does everybody understand? Only numbers that are 0 and up could have been plugged into the F machine. Does that make sense? So that means when it comes out, like it's not like all of a sudden magically you can have those X's back for all reals. This was the restriction going in. So then you need to write that because otherwise you'll think, oh, well, I can put whatever I want in there. You have to actually include that as your final answer. Does everybody understand? It's kind of like when you did rationals and you canceled the factors that were on the top and the bottom and they disappeared, but then you had to go x cannot equal whatever you canceled, right? So same thing here. Because there was a restriction going in and you would have no idea that there was one by just looking at this function, you need to add that additional restriction. Okay, so then how do we do this? f of x goes in, or x goes in and I have f of x coming out. So then I'm going to be finding g of 4 minus x squared. Was there the restriction going in? No, it's a parabola. So then when I come out here, this is now 4 minus x squared. Oh my gosh, no. Going back to that. So now we had, we don't have to worry about now that it's x has to be greater than or equal to 0, right? Because what went in there is the restriction is the radicand has to be greater than or equal to 0. So there's a difference, I guess, is what I'm trying to say is this going in had a restriction of x has to be greater than 0, the radicand there. So that follows through. Because there was no restriction going in the D question, the only restriction that comes back out is my final restriction, which is what? What would my domain be? Of course, x would be an element of reals. The radicand has to be. Okay, so we're not going to actually go 4 minus x squared is greater than or equal to 0. We actually have to solve this, right? So do you remember how to solve a quadratic? This is grade 11 pre-cal now. So we factor it. So 2 minus x, 2 plus x, right, is greater than or equal to 0. And we do a sign diagram with a 2 and a negative 2. And what are we looking for? What does greater than or equal to 0 mean? Positive. So we need to figure out what region would be positive. So if I pick negative 3 and put it in there, what do I get? Try again. 2 subtract negative 3 would be positive, and then 2 plus negative 3 would be negative. So a positive times a negative is a negative, yes? Okay, so then let's pick, say, 0. What do we get there? Positive. And then if I pick 3, what do I get there? Negative. So what's my restriction there? X is an element of reals. X must be between negative 2 and 2. Sometimes that might be easier to write square brackets around negative 2 or 2, right? Because it's greater than or equal to 0. So if it was just greater than 0, then it would be an open circle, which means it would be round brackets, right? Okay, so here's a new definition of inverses. And two functions are inverses of each other if and only if f of g of x equals x and g of f of x equals x. So let's think about this for a second. What does this really mean? X goes into the G machine and we get G of X coming out. Then G of X goes into the F machine and we get X back out. Meaning X goes in, something happens, and then X comes back out. So it turned back to each other, right? Yeah, they canceled each other out. But here's the kicker. You have to have both of them work. It can't just be f of g of x undoes stuff and I get the input back up. You also have to go the other way. Okay? So we're going to show that f of the inverse function will be the same thing as the inverse function of f of x for all values of the domain. So x goes into the F machine, and what comes out? Sorry, I need to find what the inverse function is first, right? So how do we do that? Do you remember how to do that? We switch the x and the y around. So this becomes x equals y divided by y plus 2. Everybody good with what I'm doing? This is something we learned before, so it's good review. Now what do we do? Cross multiply it over. Yeah? So x, y plus 2x equals y. Everybody good with what I did? Okay, what do we do to solve for y? We need to have all the y's on one side, right? So I'm going to say 2x equals y minus xy. Then what do I do to get y by itself? Factor out the y. So y bracket 1 minus x. Yes? Then I cross multiply it back. So I get y equals 2x over 1 minus x. So that means my inverse function is equal to 2x divided by 1 minus x. Everybody good with that? Okay, so that's only my first step. So there's my 1 marks for stating the inverse function. Okay, so all I did there is I switched the x and the y around and resolved for the new y. It's a little harder when you have a rational function, but you should be able to do it, right? Okay, so now what we're going to do is we're going to take x, put it into the inverse function, and then take that inverse function and substitute it into the f of x. Okay? So essentially we're finding this side is f of 2x over 1 minus x. Does everybody see what I'm doing here? I put x into the inverse, 2x over 1 minus x came out. Now I'm going to put 2x over 1 minus x into the f machine. Does everybody know what to do there? That means this whole input goes wherever it shows an input. Crazy, eh? So 2x over 1 minus x divided by 2x over 1 minus x plus 2. So this is good practice from when we did proofs and we had all those fractions and fractions, right? So what do we have to do? We have to get a common denominator on the bottom there. So this stays the same. This is my divide, right? And so what's 2 going to become? It's going to be 2 minus 2x over 1 minus x. Does everybody see what I did there? All I did, and maybe I'll just show my step for the people that have trouble with fractions. I'm multiplying by 1 minus x over 1 minus x, yes, to this 2 over 1. Do you see that's how I got that? Yeah. Okay, so now the 2x will cancel, yes? And what do I get? I get 2x over 1 minus x divided by 2 over 1 minus x. Does everybody see when I flip and multiply, the 1 minus x's will cancel? And then what am I left with? 2x over 2, which the 2's cancel, and I'm left with x. So that's what's supposed to happen, right? X goes into the inverse function goes into f, spews out the x again, right? Okay, so now we're going to do the inverse function of my original, which is x over x plus 2. So that's going to sub into there now, right? Remember, the definition of their inverses of each other, if and only if both things happen. We have to go both ways, right? We got to put it into one and put it into the other. So we get 2 times 2x over 1 minus x divided by, yeah, I'm putting this into there. So then this is 1 minus, oh, yeah, I see what you're saying. Oh my gosh. 2 times x over x plus 2 divided by 1 minus x over x plus 2. Is that better? This input is going wherever you see an input in the inverse, right? So, all right, what do we do now? Common denominator. I might even multiply this in, right? So that means I get 2x over x plus 2 on top. Is everybody good with that? And then the common denominator would just be x plus 2 over x plus 2 times 1, which is x plus 2 over x plus 2. So I'll show my steps. what happens when I subtract that? The x's cancel. I'll use that in red. This is almost a will of algebra, like that things all work out, like there's so much going on, right? Do you know what I'm saying? Showing your algebra strength. More, I like that. So 2x over x plus 2 divided by 2 over x plus 2. So do you see when I flip and multiply, the x plus 2's will cancel, and then I'm left with 2x over 2, which the 2's cancel, and I'm left with x. Therefore, f of x, it just says show. So therefore, f of the inverse function equals the inverse function of f of x. And now we need to do the domain of f and the domain of inverse. Oh my. Okay, so I will go back with a green pen now. Oh, this would be like at least, well, it would have to, so this is 1 mark, this would be another mark. I would think it's probably about a 6-mark question. It'd be way too much to ask in one question. I'd have to break it down. No, I guess what I'm saying is, if you do enough exams, usually the most they ask for a question is 4, because then if you can't do it, then you've only lost 4 rather than 6. So I would try to do the same thing on my test. The most I ever ask is a 4-mark question. You know what I'm saying? So then if you drop that 4, you're still, well, yeah, especially if it's only out of like 20 marks. If you drop a 4-mark question, that's like, huh? That's 20% of your mark. Anyways, so what's the domain of this one? X is an element of reals. X cannot equal -2. And what's the domain of this one? X is an element of reals. X cannot equal what? 1. It's not asking for the inverse of both together, just so you know, which would be a little bit crazy. So, okay. Okay, so this one says express each function as a composite of 2 or more functions. Verify your choice. So they're saying this is my final function. How could I make it? So this is my final function. So how could I make it? Well, let's see. I'll start you along in the first one. What happens if g of x equals 2 to the power x? How could I make it into 2 to the power 3x minus 1? What would h of x have to be? 3x minus 1. Let's see. What would I have to do to get f of x? F of x would have to be the composition of functions of g, open circle, h. Does everybody see what I did there? Okay. From here. Okay, so what happens here is x goes into the h machine, and what comes out? 3x minus 1. Then 3x minus 1 goes into the g machine, and what do I get? 2 to the power 3x minus 1. Exactly what I needed. Okay? Okay. Let's see. We're going to make f of x and h of x, and then you're going to tell me what g of x equals. So I'll give you a second to come up with 2 functions that the composition of the 2. It's kind of like yesterday when we had this quadratic, and I said come up with the product of 2 functions, and somebody said, oh, let's factor it, and then we'll get two things that multiply. Well, you're just going to have to pretend, how am I going to make this what it is, right? So there is more than one way. I don't know if anybody found a different way for that one, but okay. Did anybody come up with an f of x? 3 over x. Okay, we'll see if this works. 3 over x. And then what's h of x going to be? I'm sorry? 2 sine x minus 1. Okay, now what's the composition going to be? F open circle H. Okay, good. I'm glad you did it that way, because if you would have done it the other way, it wouldn't have worked, right? Okay, so let's test this out. X goes into the H machine, and this comes out. This goes into the F machine, and that comes out. It worked. Very good. Did anybody come up with anything different? Honestly, I don't know what you'd come up with, except that maybe you would switch these around and it would be h of f of x, right? So, okay, here's another one. Here's another one I heard. So what did you say? F of x is?
3 over x minus 1. Oh.
3. No, I think you said something different.
Because
no, you... Oh, 3 over x minus 1. Okay, we'll see if she's going to get where she's going. What's h of x going to be?
Just 2 sine x.
2 sine x. Oh, I like it. I like it, I think. And then g is going to be?
Just
F open circle H. Okay, let's test this out. Let's test this out. X goes into the H machine and 2 sine x comes out. Then 2 sine x goes into the F machine right there. Right there. And she gets what she wanted. So that's a good one too.
So it's just guess and check.
It is kind of guess and check, yeah. It uses your upper level skills for sure. Okay, given the functions, f of x is this line and g of x is this rational function, determine the equation of the composite function f of g of x and its domain. Determine its x-intercept and y-intercept. So why don't you try that? Let's try it. Okay. So I'm doing f of g of x, so I have to find f of 1 over x minus 5. So that would be 1 over x minus 5 plus 2. So maybe I should be putting f of g of x equals to make an equation there. Okay, so what's the domain of this? X is an element of the reals. X cannot equal 5. Now let's just test this out. Was there a domain restriction going in? X cannot equal 5. And then it ended up being in both, right? Thank you. What's the x-intercept? Yeah. It says to find the range on yours. And range. Oh, thank you. What's the range? Y is an element of reals. Y cannot equal 2. Now, the range, so the only thing you have to be watching for is the domain, because the domain is what's always going in, right? Okay. What's my x-intercept? We put y to 0 and solve. Maybe we need to show in my algebra. So 0 equals 1 over x minus 5 plus 2. Move the 2 over. Negative 2 equals 1 over x minus 5. Cross multiply. Negative 2x plus 10 equals 1. Negative 2x equals negative 9. X equals 9 over 2. And what's my y-intercept? We have to put x is 0, so my y would be 1 over negative 5 plus 2. So that is 2 is the same thing as 10 over 5. Does everybody see that? So what do we get? 9 over 5. Any questions there? Okie dokie. There's an exam question we've had in the past. I don't know if anybody encountered that in their studies yet. Given that f of x equals this quadratic and g of x equals that, Susie was asked to find f of g as x. This is her solution. Describe her error.
Why should we square? Why should we square? You didn't put it in for x.
Yeah. Did everybody catch that? You'd think it was her domain error, but she actually caught her domain for sure. Does everybody see? This has to go into both inputs there. Okay, so it doesn't say to actually solve it. It just says to describe the error. So Susie, darling Susie, forgot to put the square, or maybe we should call it g of x into both inputs. I'll put x's for f of x. Does everybody understand what that is? Right here, she just left it as an x. That should have went right in there. Okay, moving on. Example 8. Almost done here. Given f of x is the square root function and g of x is this line, write the equation for g of x equals f of g of x. I'm thinking this is supposed to be h of x, people, because it doesn't make sense, does it? Do you have h of x on yours? Okay, please fix this to h of x equals f of g of x, because otherwise it doesn't make sense. So I have one mistake I need to fix up there. Anyways, so what are we going to do? H of x is equal to f of g of x. That means it's f of 3x. Is there a domain restriction going in for the 3x? No. So then that's now going into this, and where do I put? 3x minus 2. Is everybody good with what I got? Okay, so what's my domain restriction? Or what's my domain? There was no restriction going in, right? But there definitely is a restriction coming out. So x is an element of reals. X has to be greater than or equal to 2 over 3. Very good. Does everybody know how I got 2 over 3? I set the inside greater than or equal to 0 and solved it, right? Yeah?
Yeah.
Okay. Moving on. Oh, explain my reasoning. What does that mean? What are the restrictions on my name? So I'll just say the radicand of, I guess, h of x must be greater than or equal to 0. Okay. Moving on, here is my f of x, here is my g of x. You need to determine the value of f dot. This is a closed circle now. What does that mean? Multiply. So watch it, right? There's a difference between open circle and closed circle. Equals 0. Okay. Then B says find the value of g of f of 4. And then C says find the value of k where f of k equals 1. So I'll give you a moment to figure it out because I don't want to just give you the answers. Okay? So I'm going to pause it. Ready? Okay. First we have to find f of 0. What's f of 0? What's f of 0? Look on the graph. What do we get as the output? Negative 1. What's g of 0? What's g of 0? 2. So f times g of 0 would be negative 1 times 2, which is negative 2. Did anybody get negative 2? Okay, so now we need to find g of f of 4. So the first thing we need to find is f of 4. So 4 goes in. What comes out? 1, 2, 3, 4. Negative 1. So then I have to find g of negative 1. Negative 1 goes in. What comes out? 3. Determine the value of k where f of k is 1. So we got to look at the f machine and see what would give us an output for 1. There is 2 possibilities. K could equal, here's an output of 1, 2. Does everybody see? And there's also an output of 1 over here, negative 3. Everybody good with that? Okay, last example. We have the parabola and a square root function, and it's asking you to sketch the graph of f of g of x. So f of g of x would be f of the square root of 1. Now here's the thing. We have a restriction going in. What's the restriction? X has to be greater than or equal to negative 1. Remember that. So now this is going into the f machine, and we have the square root of x plus 1, the whole thing squared, subtract 1. A square undoes a square root. So we have x plus 1 minus 1. Oh, that equals x. However, x has to be greater than or equal to negative 1. That's right. So how do we graph that? We have the whole y equals x line, except that it only starts at negative 1. And it includes negative 1. And then it goes like that. So does everybody see? So the domain would be x is an element of reals. X is greater than or equal to negative